Hello everyone, welcome back to my channel. In this video I'm going to be solving this paper 1-3 for Pure Mathematics 1 from October-November 2024. And so let's start. We're told in the first question that an arithmetic progression is fourth term 15 and 8th term 25. And the question says find the 30th term of the progression. And we know that for an nth term of an arithmetic progression, we use a plus n minus 1 d. Right? So if the question is saying the fourth term, it means our n is equal to 4. And for the eighth, obviously it's equal to 8. So therefore, for the fourth term, write a plus n is 4, so it's 4 minus 1 d, and we're told it's equal to 15. And this will come down to a plus 3d being equal to 15. And for the other one, we're told that the eighth term is 25, so we do the same. A plus 8 minus 1 d is equal to 25. So a plus 7d is 25. Now with these two equations, we can get a and d, solving them simultaneously. Right? So I can choose to make a the subject in the first equation, and that will give us a is equal to 15 minus 3d. And I'm going to substitute this a in the second one. So in place of a, I'm going to write 15 minus 3d plus 7d should give me 25. Now from here, I'm going to say 15 plus 4d should give me 25. And my 4d is equal to 25 minus 15, which is 10. And dividing by 4 both sides, I get my d to be 5/2. Right? And I'm going to substitute this value of d back into the first equation to get a, which is the first term of the progression. So a is 15 minus 3d, and this will give us 15 minus 3, 5/2. This is giving me 7.5. Now we have the first term of the progression and d, which is the difference, right? And to get the 30th term, we're just going to say our a plus, our n is 30, so that's 30 minus 1 d, right? And this is the reason why we had to get a and d first, because we knew for an nth term in an arithmetic progression, we refer to this formula right here. So with our a, which is 7.5, and our d, which is 5/2, our 30th term comes down to be 7.5 plus comes down to be 80. And you get your 3 marks for number 1 there. Moving on to the second question, it says find the exact solution of the equation cos a 6th pi plus tan 2x plus root 3/2 equal to 0 for x being taking a value from minus a quarter pi to positive quarter pi. So we're just going to punch in this in radians because we're dealing with pi's. So cos a sixth pi is giving us root 3 over 2, and we have tan 2x plus root 3 over 2, and this should give us 0 like this. So we can add these two. This is like half root 3 plus half root 3, so we get root 3 plus tan 2x being equal to 0, and tan 2x will be equal to negative root 3 like this. So to get our 2x, we say 2x is equal to the tan inverse of negative root 3, right? And so we're going to get our principal value here with these 2x. So tan inverse of negative root 3 is minus a third pi like this. And so our 2x is equal to minus a third pi, and so our x will just be minus 1 over 6 pi like this, and that will be our answer for the second question. And as you can see, they said find the exact solution, meaning that we don't have to simplify this to get minus 0.523. We just leave it as this. So whenever they say exact, you leave your answers in terms of pi or with square roots and fractions, right? And for the third question, we're told, it says find the coefficients of x to the power 3 and x to the power 4 in the expansion of 3 minus ax to the power 5, where a is a constant, and give your answers in terms of a. So for us to get a term in x to the power 3 here, we'll have to choose 3 from 5. This is a bit of a binomial expansion, so we'll say 5 choose 3, so that we'll go on and say ax to the power 3, and this will give us a term in x to the power 3. Then our 3 to the power 5 minus 3, which is 2, like this. So 5 choose 3 times our 3 squared, which is obviously 9, is 90. So this 90 is being multiplied to minus a to the power 3 and x to the power 3. So it gives us minus 90 a to the power 3 and x to the power 3. And this is our term in x to the power 3. And we do the same to get the term in x to the power 4. So we're just going to choose 4 from 5, then minus ax to the power 4, and 3 to the power 5 minus 4, which is 1. So 5 choose 4 times 3 is giving us 15. So saying 15 times our minus a to the power 4 and our x to the power 4. So this will be positive 15 a to the power 4 and x to the power 4. And this will be the term in x to the power 4. So our two answers for this part of the question are minus 90a to the power 3 x to the power 3 and 15a to the power 4 x to the power 4. Oops, they said coefficients, so only taking this part. So for this one it will be minus 90a to the power 3, and for this one it will be 15a to the power 4. This is the coefficient. And for part B, it says given that the coefficient of x to the power 4 in the expansion of that is 240, find the positive value of a. So for us to get a term in x to the power 4 here, if you look at this closely, you can see that this is what we were dealing with in part A. So for us to get a term in x to the power 4 of this whole thing, it will be from us multiplying this ax and the term for this bracket, that is to the power 3. Because if you multiply this and the term with x to the power 3 here, our result will be a term in x to the power 4. And when we multiply this 7 by the term in x to the power 4 for this bracket, we'll get a term in x to the power 4, and we add the 2. And that's how we're going to do it. So we already have the term for this, that is x to the power 3. So going to multiply that by ax. So it's ax, and our term in x to the power 3, that's our minus 90 x to the power 3 a to the power 3, and this will be our minus 90 x to the power 4 and a to the power 4, right? And multiplying 7 by the term in x to the power 4, which is right here, it's our 7, 15a to the power 4 and x to the power 4. We get our 7 times 15, that's 105a to the power 4 and x to the power 4. So adding these two, we'll get a term in x to the power 4 for this whole thing that we're given here. So we have 105a to the power 4 x to the power 4 minus 90 x to the 4 a to the power 4, and we're told the coefficient is equal to 240. So the coefficient would just be 105a to the power 4 minus 90a to the power 4, and this is equal to 240. So 105 minus 90, that's our 15a to the power 4 being equal to 240, and we divide by 15 both sides to get our a to the power 4 as 16. And to get a, we're just going to say the quad root of 16, and we're only considering the positive one. So go ahead and say the quad root of 16, we know it's 2. So our a is equal to 2. And for the fourth question, say solve the equation 4 sine to the power 4 theta plus 12 sine squared theta minus 7 is equal to 0. For theta taking values from 0 degrees through to 360 degrees. And as you can see, this power right here is twice this one. So we call this a disguised quadratic. So we're just going to go ahead and say 4 sine or let's start by saying this instead. Let sine squared theta be x, right? So that we turn it into a form that we are more comfortable with. So 4x squared plus 12x minus 7 is equal to 0. Right? So now x is standing in for sine squared theta. So we solve this. We can use the quadratic formula. So x will be equal to minus 12 plus or minus 144 minus 4, our a is 4 and our c is minus 7, all this over 2a, which is 4, and this will give us two x values, which are minus 12 plus root of 144 minus 4 minus 7 over 8. It's giving us half, or the other value where we use minus, it's minus 3.5, right? And we know that our x is standing in for sine squared x. So from here now we then go ahead and say our sine squared theta is equal to half, or our sine squared theta is equal to minus 3.5. And we solve these two separately. So to get sine theta, we introduce the square root on both sides. So sine theta is equal to plus or minus root of half, which is the same as saying plus or minus 1 over root 2, but we just keep it like this. And for this one, if we try and introduce the square root on both sides, this will give us an error. So we're discarding it, and we're left with these, right? So for this particular question, I'm going to try and use the cast method. And for that, we have to ignore these two signs first. So we just take them to be positive. So ignoring those signs, we say sine theta is equal to this right here. And we get our principal value by saying theta is sine inverse 1 over 2. And punching this, we get root 1 over 2. Oops. We get, my calculator's doing radians. In degrees, we get 45 degrees. We're getting 45 degrees like that. And now, considering our cast diagram, where we say in the first quadrant, we take the principal value as our answer, and this A stands for all, and we're saying in that quadrant, we're considering all our trigonometric functions, our sine, our tan, our cosine, to be positive. So they are all positive in the first quadrant, and in the second it's only the sine. So this S stands for sine, and our answer would be 180 minus the principal value. So whenever we have a positive sign, for example in this sine theta being equal to a positive, right, we'll be considering the first and the second, because we know in the first quadrant all of these are positive, and in the second sine is positive. So in the third, it's only tan that is positive. So if we have tan theta of something being equal to a positive number, we consider the third and the first, right? And for cos is the fourth quadrant and the first. So if we have a positive cos, for example, cos theta being equal to 1, for example, which is obviously positive, we'll be considering the first quadrant and the fourth. And for the third, it's 180 plus the principal value, and for the fourth, it's 360 minus the principal value. So let's say we're given maybe sine theta being equal to a negative. So for a negative, it's the third and fourth, because we know sine is positive in the first and second. So if we're given sine theta being equal to a negative, we'll consider the third and fourth. And we do the same for these other trigonometric functions. Alright, so now from here we go back to these two signs, where the positive and a negative. So for the positive, it's like taking this sign to be equal to a positive. And like I said, we consider the first quadrant, which is our principal value. So our first answer will be 45 degrees. And the second one, which is 180 minus 45, which will give us 135 degrees, right? When we're getting these two answers from sine theta being equal to a positive. And now considering the negative, we said we'll be taking answers from the third and fourth, because we know from the first and second quadrant sine theta is positive. So in the third and fourth quadrants, it is now negative. So now we take our 180 plus PV, which is 225 degrees, and our 360 minus 45, which is our 315 degrees, and we get our four answers like this. Then we just check to see if they all fall within this range, and as you can see, they are within the given range, which is going from 0 degrees to 360. So we're taking all four in as our answers to get our 4 marks for the fourth question. And for the fifth question now, we're given a diagram, and it says in the diagram the graph with the equation y equals f of x is shown with solid lines, and the graph with the equation y equals g of x is shown with broken lines. Part A says describe fully a sequence of three transformations which transforms the graph of y equals f of x to the graph of y equals g of x for 6 marks. And so looking at this diagram, we can see that this graph with broken lines is in a flipped shape of this one, right? You can see this part on this one is over here, and this horizontal part over here, and this one. You know, that's one of the characteristics of reflection. So if we have reflection and we have this, it will be flipped for the other part, and we'll be having the same distance of the two from the mirror line. So looking at this now, I've seen that there is a reflection. Looking at this, it will have to be in the y-axis, right? Let's take it to be that and see where we end up at. So if we reflect this in the y-axis, we'll get something like this. We'll get something like this as a result, right? And now with this, we can see that this part is a point from the mirror line. So it's like moving this 1 unit to the left. So moving it 1 unit to the left, we are now having it like here. So it will be this first, this, and this. But if I'm not mistaken, oops, this is only covering one box, so it's like this. like so. And now for the last transformation, we look at the y-axis. We can see that for this one, this part is only covering 2 boxes, 1, 2, and this part is covering 1, 2, 3, and 4, right? So if we say that 4 over 2, obviously we get 2, meaning this has been stretched by a factor 2 in the y direction, right? So summarizing all that now, we will be saying, first of all, we had a reflection in the y-axis, meaning the y-axis was our mirror line, reflection in the y-axis, and it was followed by a translation in the x-axis by 1 unit to the left, right? And this was followed by a stretch in the vertical axis or the y-axis by a factor 2. And these are the transformations that we were being required to fish out. And for the second one, it's good to understand that you can also write it as a vector, and it will be -1, 0 as a vector. So you just say a translation by a vector -1, 0. And it will mean the same as saying it's a translation in the x-axis by 1 unit to the left. And that's it for number 5, part A. And for part B, it says find an expression for g of x in the form a f bracket bx plus c. So we're going to follow this order from 1 to 2 and 2 to 3 to go from f of x to g of x. So we had f of x to start with, and there was a reflection in the y-axis. So reflection in the y-axis would be shown by this, multiplying that x by -1 d inside the bracket. And for the reflection in the x-axis, that's when we put the minus outside the bracket. But for the one in the y-axis, we put the minus in the bracket like this. And this is after the first transformation. And applying the second to this, we know it's affecting the x-axis, right? So for that now, we have our f, our minus for this, but we put a bracket because we know it's directly affecting the x, right? We don't just go ahead and put a +1d, but we put our x, then we put a +1. And it is also good to understand that whenever we're talking about translations in the x-axis, if we're talking about moving to the left, which is obviously a minus when we write it as a vector like this, in the equation we put it as a plus like this. You can see that it's x plus 1, but we're talking about moving to the left, and it's obviously a minus. So when we're moving to the right now, we write it as minus. So it will be x minus 1. And this represents a horizontal translation in the x-axis by 1 unit to the right. So we write it this way, keeping our minus like this. Then after this, we know there was a stretch in the vertical axis by a factor of 2. So a stretch in the vertical axis affects the y-axis, and we know we usually write equations as y equals 2x plus 2x squared plus 3x, something like this. So if anything is affecting the y-axis, it's also affecting this whole thing, right? And for that, we know we're going to multiply this by 2 because it's being affected by that 2 being a factor of a stretch. So we put it here to show that it's multiplying everything. So we'll end up with 2f, then our minus x plus 1, like this, and this will be our g of x for 2 marks. And that's number 5, part B. And for the 6th question, it's saying the first term of a convergent geometric progression is 10, and the sum of the first 4 terms of the progression is p, and the sum of the first 8 terms of the geometric progression the sum of the first 4 terms of the geometric progression is p, and the sum of the first 8 terms of the progression is q. It is given that q over p is equal to 17 over 16, and the question is find the 2 possible values of the sum to infinity. So firstly, we need to understand that a convergent geometric progression, which we can also call a convergent geometric series, is an infinite series with the sum of its terms approaches a finite, which is a fixed value. So that's what we mean by a convergent geometric progression. We're saying we have an infinite series where the sum of its terms approach a finite or a fixed value. That's all we mean by saying a convergent geometric progression, a convergent geometric series. And for this particular question, we are told the sum of the first 4, so that we use the formula that we're given in the M of 19, which is Sn is a1 minus r to the power n over 1 minus r, right? And we're told that the sum of the first 4 terms is p. So p is equal to a over 1 minus r. We know our n is 4, right, over 1 minus r. And the sum of the first 8 terms of the progression is q. So q is a bracket 1 minus r to the power 8 over 1 minus r. And this is our second equation. And the third one we're given in the question, it's q over p is equal to 17 over 16, like that. And so we can make q the subject, so q will be equal to 17 over 16p, just us multiplying by p both sides. Right, so now with this, we know this q is always equal to this one, so q is always equal to q, therefore this part should be equal to this part. So our a 1 minus r to the power 8 over 1 minus r should be equal to 17 over 16p, right? And we will need r and a to get the sum to infinity, because we know for a geometric progression, sum to infinity is a over 1 minus r. That's why we're setting up these equations to get the value of a and r. So now with this, we can go ahead and make P the subject. Wait, I think that would take us long to get to your answer. Let me try another method. So if we look at what we're given, we have P and Q, and P is this. Let me just rub this so that this is clear. We have P being equal to this and Q being equal to this. And the question told us that Q over P is 17 over 16. So our Q is A1 minus R to the power 8 over 1 minus R. And if we divide this by this, which is our P, we should get 17 over 16. Now I think that's better. So we're saying A1 minus R to the power n over 1 minus R should give us 17 over 16. Yeah, this is a better method than what I had started with. So for this, we know we're just going to flip this around. So A1 minus R to the power 8 over 1 minus R times 1 minus R over A1 minus R to the power. Did I use n there? For P is the fourth term, so n is 4. 4 like that, and this should give us 17 over 16. 1 minus R cancels out with 1 minus R, and A with this A, so 1 minus R to the power 8 over 1 minus R to the power 4 is 17 over 16. Now this makes more sense. 16, 1 minus R to the power 8, we just cross multiplying, is equal to 17, 1 minus R to the power 4. So 16 minus 16 R to the power 8 should give us 17 minus 17 R to the power 4. Now taking everything to the right hand side, we get 16 R to the power 8 minus 17 R to the power 4 plus 17 minus 16, that's 1. Should give us 0 like that. We can see that this power is twice this one. And so again, we're faced with a disguised quadratic. So we can say let x be R to the power 4. So that we say 16 x be R. This is 16 to the power 8. 16x squared minus 17x plus 1 is equal to 0. And from here we can use the quadratic formula. So x will be 17 plus or minus 17 squared minus 4a, and our c is 1 over 2a, which is 32. Then we get our two values of x to be 17 plus root of 17 squared minus 4 over 32, that's 1. And for the other one, we get 1 over 16. But we know x is standing in for R to the power 4. So we come back here and we say R to the power 4 is equal to 1 or 1 over 16. So to get R, we are saying quad root. So R will be quad root of 1 or quad root of 1 over 16. And this is going to give us 1 or 1 over 2. So these are the two values of R we have. But if we look at these formulas from our MF19, it states a condition there that we need to consider. It says R should not be equal to 1 for this to be true. So we're going to discard this one and take our R to be half. Right? So we're going to discard that and take our R to be half. So now to get A, we are just going to pick one of these equations. So which one can we use? Let's use this one. Let me try and make space here. Right, so Q is equal to A1 minus R to the power 8 over 1 minus R. How many marks is this? 5 marks. Wait. The first term, A we already given is 10. So we know A is 10. So that makes it simple. So our sum to infinity is A over 1 minus R. So it's 10 over 1 minus a half, which is 10 over a half, which is 20. Right, for the first one, it's 20. And the reason I'm saying the first one is because they said find the two possible values of the sum to infinity. So let me try and see where the other one is coming from, because we know the first answer is 20. I see. For R here is plus half or minus half. So if we have half and we say to the power 4, we get 1 over 16. And if we have minus a half and we raise it to the power 4, we get the same answer. So we have two values of R, which are positive half and a minus half. So now we get the other answer by saying 10 over 1 minus half. Right, which is 10 over 3 over 2, which gives us 20 over 3, and this will be the second answer. And this should get you your 5 marks for number 6. And moving on to the 7th question. This is a pretty long one. The diagram shows the metal plate A, B, C, D, E, F consisting of 5 parts. The parts B, C, D, and D, F are semicircles. The part B, A, F, O is a sector of a circle with center O and radius 20 centimeters. And D lies on this circle. I'm sure you can see that on the diagram. And the parts OBD and ODF are triangles. Angles BOD and DOF are both at about theta radians. And given that theta is 1.2 radians, find the area of the metal plate. Give your answer correct to 3 significant figures. So we're given this funny looking diagram here, and we're asked to calculate the area. And we're also told that this theta is 1.2 radians. So what we're going to do here is to first get the area of this. Then we get the areas of these two triangles. I'm sure you can use half AB sine theta to get those two using this angle and the two sides making the angle. Then we're also going to get the areas of these two semicircles. But for the semicircles, we do not have the r values, right? So it's kind of impossible to get those areas without the values of r or the whole diameter right there. So we're going to try and get that. So we are going to connect this. We can use either one of these, and we know this angle is 1.2, so dividing it by 2 to get this and this, we get our 0.6 for this part, and we know this is 20. And to get our r is opposite, right? So opposite over hypotenuse, which is 20, is our r over 20, and this should give us opposite of hypotenuse, the sine should give us sine 0.6. And with this, we're going to get our r to be 20. R is 20 sine 0.6. 20 sine 0.6. Wait, let me change my calculator to radians, giving me 11.29. So that's my r. So I'm going to, I know it's the same for this one as well, so I'm going to use this r to get the areas of those two semicircles, and that should be it. So area of this, for area of this, I'm going to need this angle for area of this part. I know this is 1.2 and 1.2. So I know 360, that's our 2 pi, minus, this is 1.2 plus 1.2, so that's 2.4. 2.4, it's giving me 3.883. So that's this angle right here, which we're going to use. So for a of that, we're going to use theta over 360, which in this case is 2 pi times pi r squared, right, to get the area of this region. Right, so our theta, which is 3.883 over 360, 2 pi, like that, times our pi r squared. Our r is 20, so that's our 20 squared. You can see that the 2 pi's cancel out there, so we are left with 3.883 over 2 times 20 squared, and that is giving us 776 and 3 over 5, because that's square centimeters. And for the two triangles, we're going to use half AB sine theta, with A and B being the two sides that are making the angle theta. So half, or A and B, we know they're both 20, so we can say 20 squared, and sine theta, which is 1,2. So 20 squared of 20 squared over 2, and sine 1,2. That is giving us 186.4, and we're going to multiply this by 2 because we have two triangles that have the same dimensions. So that will be 372.8. Again, it's square centimeters. And for these two semicircles with an r value of 11.29, we are going to say the area of a full circle is pi r squared, right? So for a semicircle, it's half of that, half pi r squared. So we're just going to say half pi, our r squared is 11.29 squared, 11.29 squared, and this is for one of the two. So half our pi, our r squared is 11.29 squared and that is giving us 200.22, and we know it's the same for the other semicircles also. Might as well multiply this by 2 and get 400.44 square centimeters. So to get the area of the metal plate, we're just going to add these three. Alright, so 400.44 plus our 372.8 and our 776 and 3/5, and that is coming down to be 1549.8 square centimeters as the area of the metal plate. And they said give your answer in 3 significant figures. So this in 3 significant figures, this is the first one, the second one, and the third. So that will be 1550, like this, square centimeters. Alright, and part B is saying given that the area of each semicircle is 50 pi square centimeters, find the exact perimeter of the metal plate. So if we have the area of each of the semicircles, each one of the semicircles being 50 pi, it means half pi r squared for one of those is 50 pi, like this. And as you can see, these two cancel out, so half r squared for that is 50, and multiplying by 2 both sides, we get r squared being 100 because we're multiplying by 2, and our r, which is obviously positive, is root of 100, which is 10. So the radius of these small semicircles, of one of the two semicircles, is 10, which is the same as the one for the other one. So to get the perimeter of the metal plate, which is the distance right around this metal plate, we're just going to get the length of this arc, the length of this one, which is equal to this one, and that should be our perimeter. And for this one, we know we just use our theta, arc length, and we'll be considering this. Right, and this time we are not using theta equals 1,2 because that was for part A. That was specifically for part A, and for part B we have to get our own value for theta. So now we know that r for this is 10, right, and this is 20, so we can surely get this part, which we can call x, which is half of the theta, right? So we're still saying sine theta is 10/20, right? So our theta will be sine inverse of half, and in radians, sine inverse of 0.5 is a 1/6 pi. So having theta to be 1/6 pi, this whole angle, which is theta plus theta, will be 1/6 pi plus 1/6 pi, which is 2/3 pi, right? And for perimeter, we are going to need the length of this arc, and for us to get that, we use the angle that is in the arc, which is this, and you know this whole thing is a complete revolution, which is 2 pi, and we're going to subtract 2/3 pi from that to get this angle right here. So it will be 1 1/3 pi. And for this length, we are going to use r theta. Our r is 20, so 20 times, this is 4/3 pi, and that will give us 80/3 pi, like that, for the length of this arc. And for the length of each one of these semicircles, note the length of the circumference is pi d, and we've seen that our radius is 10. So to get the length of a semicircle, it should be pi d divided by 2, since it's half the circle. So we're saying our diameter, that's 2 times 10, which is our radius, 20/2, and this is giving us 10 pi, like that, as the length of one of these. But we have 2 of them, so you're just going to multiply this by 2 to get 20 pi. So then we come down here and we add this 20 pi to this 80/3 pi, and so it will be 20 pi plus 80/3 pi. We want it to be exact, so we just add these. So that's our 3 60 plus 80, and this gives us 140/3 pi to be the length, to be the perimeter of the metal plate, and you get your 5 marks for that. Says express 3x squared minus 12x plus 14 in the form that, which is a completed square form, where a and b are constants to be found. So as you can see, 3 was factored out, so we don't divide, but we factor out, and for that we introduce square brackets. So that will be x squared minus 4x plus 14/3, like this, and then we complete the square for this part, and after we're done, we multiply everything by 3. That will be x minus 2 squared plus 14/3 minus the square of this, which is 4, right? All this without 3. So now we say 3 is multiplying x minus 2 squared, then we simplify that with our 14/3 minus 4. It's giving us 2/3, and 2/3 multiplied by 3, we get 2, right? And so we get this, which is in that form, for 2 marks. And for part B, we are told the function f of x is this, which is what we were dealing with in part A, for x being greater than or equal to k, where k is a constant, meaning k is just a number. And for part B, for the question, find the least value of k for which the inverse of f of x exists. So we're looking for the least value of k for which the inverse exists. So the inverse of f of x will only exist if our function f of x does not have a turning point. So when you're looking at it, when you're looking at this, we can see that the coordinates of our turning point are 2 and 2, right? Meaning, you can see that there is a positive coefficient of x squared, meaning it's facing upwards like this. So sketching it to be like this. So for this, which we are assuming to be our f of x, to be having an inverse, it should not have a turning point, right? So it should either be just this one part or this one part, right? So the least value of k, because we know x is greater than or equal to k, and we're talking about the x values, so we're referring to this. right? So our x is greater than or equal to 2, right? Meaning, if I can draw it again, the turning point is at 2, 2, like that. If x is greater than or equal to 2, we are only considering this part of f of x. And as you can see, it doesn't have a turning point, right? So if we can use the graphical method, we can see that for this region, these lines only have one x value for each of the y values, which is one of the tests that we can use to see if a graph or a function has an inverse, right? So that's why we picked 2 there. X is greater than or equal to 2. 2 is the x coordinate of the turning point. So if we're taking values that are greater than or equal to 2, we're only referring to this one part of f of x, and that is an inverse because it doesn't have a turning point. So you do that for a mark there. And says for the rest of this question, you should assume that k is the value that you found in part B, which is 2. So it says find the expression for the inverse of that. So instead of using this, I'm just going to use the completed square form, right? So I know my f of x is equal to 3x minus 2 squared plus 2. And for me to get the inverse, I'll just say this is my y, and it's equal to 3x minus 2 squared plus 2. Then I swap the y for x and the x for y. So this will be x is equal to 3 y minus 2 squared plus 2. Then I make this y the subject. So trying to make that y the subject, I will get the inverse. So x minus 2 over 3 is equal to y minus 2 squared. And then I introduce the square root sign both sides. So I'll get plus or minus root of x minus 2 over 3 is equal to y minus 2. And to get y, it's 2 plus or minus root of x minus 2 over 3, which is equal to y. And as I've said, this y is standing in for the inverse, like this. But we cannot take two signs. Yeah, we have to pick one. And for that, we are considering this, right? So usually, whenever you see a greater than or equal sign, you are saying this has to be greater than or equal to 2. Because remember, this is now the expression for the inverse. And this is the domain of the original. We know that the domain of original is equal to the range of inverse. So this domain should be equal to the range, and the range is this part of the inverse. So that's why I'm saying this should be greater than or equal to 2. So for it to be greater than 2, we have to take the positive, right? For this to be greater than or equal to 2, we're taking the positive. Because if we take minus, it will mean that we'll be getting values that are less than or equal to 2. So for us to get values that are greater than or equal to 2, we are taking the positive. Or you can just say, whenever you see a greater than on the domain of the original there, you're taking the positive. And whenever you see a less than or equal to, you take the negative. And that can also work. So here we are taking the positive. And for part D, it says hence or otherwise. Hence meaning we might have to use answers that we got from the previous questions, and otherwise meaning we can just go ahead and do it straight away. Solve the equation f of x equals 29. So in f of x, we are going to substitute f of x where there is x. So we know f of x is 3 then our x minus 2 squared plus 2, x minus 2 squared plus 2. This is our f of x, and in this expression for f of x we're going to substitute f of x. So it's 3, then 3x minus 2 squared plus 2 in place of this x. Then we say minus 2 squared plus 2. We just put f of x where we have x here, and so it's 3x minus 2 squared plus 2 minus 2 squared plus 2, and these two will cancel out, multiplying these two. Oops, wait, there's a squared here, so we have 3x minus 2 squared, and this is being squared, so this 3 is being squared and this bracket is being squared, so it's 3 squared, that's 9, and squaring the bracket we get x minus 2 to the power 4, and this is 2 being added to it. So 3 times 9 will give us 27, x minus 2 to the power 4 plus 2. And we're told in the question that this is equal to 29. Right? So to solve this, we're going to move this 2 to the other side. Then we divide both sides by 27. So x minus 2 to the power 4 is equal to 27. 29 minus 2, and dividing both sides by 2 to get rid of this 27, we get x minus 2 to the power 4 being equal to 1. So then we introduce this, the quad root of that will be x minus 2, and that's going to give us plus or minus 1, right? And for x, x will be plus or minus 1 plus 2. So x will be equal to 3 or 1 minus 2 minus 1 plus 2. X is equal to 3 or 1, like that. And those will be the two solutions for D. I'm just trying to check and see if we're taking both of them in. Yep, so I think we can take both of them in, but I'm also thinking, since we have f of x in there and we know x is greater than or equal to 2 for f of x, I think we will be taking x equals to 3 because it is the only value that's greater than 2. So if we're considering that, we have to discard that one. Right, number 9, it says, given yet another funny looking diagram. It says the diagram shows the curves with equations y equals that and y equals that. It says find the x coordinates of the points of intersection, and as you know, to get coordinates of points of intersection, you just equate the two equations, because at that point we have the same y values, so you can say y is equal to y, so you just equate these two. So to do that, we say x to the power 3 minus 3x plus 3 should be x to the power 3 minus 4x squared plus 3, like that. Taking everything to the right hand side, you can say 0 is equal to 2x to the power 3 minus that, we get x to the power 3, then minus 4x squared, this is minus 4x squared plus 3x, then that will be 3 minus 3, that will give us 0. And for this, let me just write it like this. So it's like this. I'm going to factor out x first to get x squared minus 4 x plus 3 equal to 0. Now with this, we're going to say this x is equal to 0 or this is equal to 0. Right? So we will say x is equal to 0 or x squared minus 4x plus 3 is equal to 0. Now we'll try and get solutions of this, and we can use 1 and 3 to get that. It's minus, so x squared minus 3x minus x plus 3 should give us 0. So x minus 3 minus 1, x minus 3 should give us 0. So we're getting x minus 3 and x minus 1 being equal to 0. And solving that, we get x is equal to 3 or x is equal to 1. So we have three values of x equals to 3, x equals to 1, and x equals to 0. And looking at this, we have this point of intersection here, this one, and this one. And as you can see here, x is equal to 0. And this is for this one, x equals to 0, and for this one, so 0, 1, and 3. So we're taking x is equal to 3 for that, x is equal to 1 for that, and x equals to 0 for that. So those are the x coordinates of the points of intersection for 3 marks, meaning one of each. For part B, it says find the area of the shaded region. Find the area of the shaded region. That's the area between two curves, and we know for that we use integration. So we say the integral of the one above minus the integral of the one below, using these x values as limits, because we're only considering this region. So we're going to use x equals to 1 and x equals to 3 as limits. But we're saying integral of this, which is on top, minus integral of the one that's below that. Right, so it will be looking like integral of the one on top is x to the power 3 minus 3x plus 3. X to the power 3 minus 3x plus 3. Then we subtract the integral of the other one, which is 2x to the power 3, 2x to the power 3 minus 4x squared minus 4x squared plus 3, like this. And we're using 3 and 1 as our limits for that. And we're integrating these with respect to x. That's why I'm putting those dx's. For integration, we're adding 1 to the power and dividing by the new power. So x to the power 4 over 4 minus 3x squared over 2 plus 3x minus this 2x to the power 4 now over 4 minus 4x to the power 3 over the new power, that's 3 plus 3x. Alright, and before we use our limits, let's just simplify this. X to the power 4 over 4 minus 3 over 2x squared plus 3x minus x over 4 over x to the power 4 over 2 plus 4 over 3x to the power 3. I'm now multiplying this by this minus 1 minus 3x, and for this now I'm going to apply 3, 1 limits. So substituting 3, we get 3 to the power 4 over 4. 3 to the power 4 over 4 minus 3 over 2, 3 squared, that's 9, plus 3, 3 minus 3 to the power 4 over 2 plus 4 over 3 3 to the power 3 minus 3 and 3, and that is giving us 2¼ Then we subtract the value we get after substituting 1, which is obviously 1/4 minus 3/2 plus 3 minus 1/2 plus 4/3 minus 3, and that's minus 5/12, and this is going to give us a plus. So this plus 2¼ is giving us 2 2/3, and this is area, so units should be squared. 2 2/3 square units. We are almost done. It says show that the center of the circle lies on that line. Show that the center of the circle lies on that line. So we're going to try and get the coordinates of the center, then we substitute them into this equation of a line, and if it makes sense for us, then that will be us having shown that the center lies on that line. And so for that, we're going to consider the general equation of a circle, which is x minus a squared plus y minus b squared being equal to r squared. Since a and b are on the circle, we're going to substitute them separately. So first we're going to substitute 4, 3. So x is 4 there, so 4 minus a squared plus y, which is 3 minus b squared, should give us r squared, which is 10 squared, 100. And for the other one, we're going to say 8 minus a squared plus minus 5 minus b squared should also give us 100. Right? And now 100 is equal to 100, so this should be equal to this. So 4 minus a squared plus 3 minus b squared should be equal to 8 minus a squared plus minus 5 minus b squared. Right? And this will be 16 minus 8a plus a squared plus 9 minus 6b plus b squared being equal to 64 minus 16a plus a squared, which is being added to our 25 plus 10b plus b squared. Now we're just going to simplify this. Right, so we have b squared on the left hand side and b squared on the right hand side, so that will cancel out. A squared on the right and a squared on the left, like that, and that will cancel out. Right, so we're left with 16 minus 8a plus 9 minus 6b is equal to 64 minus 16a plus 25 plus 10b. Simplifying the right hand side with 64 plus 25, that's 89. So 89 minus 16a plus 10b. And here we have 25 minus 8a minus 6b. Okay, so we can take everything to the right hand side. 89 minus 25, that's our 64. So 0 is equal to 64. Then minus 16a plus 18a plus 8a, that's minus 8a. 10b plus 6b, that's plus 16b. And if we divide everything by 8, we get 2, 1, and 8. So in other words, we are saying 2b minus a should give us minus 8, like that. And making a the subject, get 2b plus 8 is equal to a. Must have taken a very long route. Either way, we can still get to our answer. So let me clear some space here. So now with this, I'm just going to substitute it back into this one. So I know a is 2b plus 8. So x, which is maybe 4 minus 2b plus 8 for a, and this is being squared, plus our y for that particular coordinate, which is 3 minus b squared, should give us 100, like this, right? So this is 4 minus 2b minus 8, so minus 4 minus 2b squared plus 9 minus 6b plus b squared should give us 100. So 16, right? So that's 16 minus, that's 8 plus 8 plus 16b plus 4b squared plus 9 minus 6b plus b squared is equals to 108. Simplifying that, we get 5b squared, right? Then 16 minus 6, that's plus 10b, then plus 25 is equal to 100. And taking that 100 to the left hand side, 5b squared plus 10b, 25 minus 100, that's minus 75. And we can divide by 5 throughout to get b squared plus 2b, then minus 15 is equal to 0. And to get b, we can use our quadratic formula. So b should be minus 2 plus or minus 2 squared 4 minus 4ac minus 15 over 2. And this should give us our b to be 4 minus 15d over 2, and our b is equal to 3, or let me see if we can get another sensible value, or minus 5, right? And these are the two values of b that we have. And for a, we're just going to substitute them back here. So 2, 3 plus 8, that's 6 plus 8, and that will give us 14. A being equal to 14, and 2 minus 5, that's minus 10 plus 8. A should be minus 2, right? Like that. So our center is AB. So we have two sets of values here. We have 14, 3, and minus 2, minus 5. Just going to substitute these into this. Alright, so our y is 3. We're going to substitute 14 on the other side. Half or 14 minus 4. We're getting 3. Meaning if we put 3 here and 14 here, this is making sense. So this is on that line. Let me just try and see if the other one proves to be true as well. So that's minus 5. We should get minus 5 by saying half x minus 4. So half x, our x is minus 2, and our minus 4 is minus 5. So both of them are on this line. So we've shown that the center of the circle is on that line. So you just put this down here and you substitute each one of these. So these are the two values that we have for the center. It can either be this or this one. Although I feel like I took a very long method. I'm sure you guys have shorter methods. But this proved to work out pretty well. Yes, I feel like this was the right way to do it, because B is now saying find the two possible equations of the circle. So for us to get two possible equations of the circle, we need two possible values of the center, right? And the general equation of the circle is our x minus a squared plus y minus b squared being equal to r squared. So for the first one, we're going to use this value of the center, 14 and 3. So it will be our x minus 14 squared plus our y minus 3 squared being equal to 100, which is 10 squared. So this is the first one. And for the second one, just going to use the other one, minus 2 minus 5. So that's our x minus 2 squared plus our y minus 5 squared being equal to 100. Simplifying it, we get x plus 2 squared plus y plus 5 squared being equal to 100. And you see that they put that for 5 marks. So they weren't expecting you to get these two values, these two coordinates of the two possible centers. So if you had used any other method to which gave you 1, you were going to have to do a bit of working for the part B1, where you needed to get the other equation. But if you had done this and had gotten two coordinates for the centers, you're just going to use that. You're just going to use those for part B to get your 5 marks in less than 30 seconds. And number 11, which is the last question on this paper, is saying the equation of a curve is that where k is a constant, meaning k is just a number. Find the first and second derivative in terms of k. Just going to differentiate this. So differentiating that, we get first derivative to be, take the power down, subtract 1 from the power, so that will be minus half. And again, we're taking the power down, subtracting 1 to the power, we're left with x. And if we differentiate a constant, which is just a number without a variable next to it, we get a 0. So our first derivative, which is dy dx, is half k x to the power minus half minus 8x, like this. And differentiating this for the second time to get the second derivative, we're going to take the power down again. So this times this, we get minus 1 over 4 kx, and we're going to subtract 1 from the power again. So that's minus 3 over 2 that we get. And for this, we get that, because we're going to take the power 1 down, which gives us minus 8, and x to the power 1 minus 1, which is to the power 0, and that will give us that. So we get 2 marks for that. And it is given that k equals 2, says find the coordinates of the stationary point and determine its nature. So first we're going to have to substitute k into these two. So for dy dx, if k is 2, it's going to cancel out with that, so that will be x to the power minus half minus 8x. This is for dy dx. And for the second derivative, with this being 2, we're going to have minus a half x to the power minus 3 over 2 minus 8. And to get the coordinates of the stationary points, we know that at stationary points dy dx is equal to 0. So we're just going to go ahead and say this equal to 0. X to the power minus half minus 8x should give us 0. So this is 1 over root of x minus 8x equals to 0. 1 over root of x being equal to 8x, like that. And if you multiply everything by root of x to clear out that fraction, we get 1 being equal to 8x, this x to the power 1 times x to the power half. So we add these two. So 1 is equal to 8x to the power 3 over 2. Then we divide by 8 both sides. We get this. And to clear out this power, we raise to the power the reciprocal, which is 2/3. 2/3, like that, because we know this will cancel out to give us 1. So x is 1 over 8 to the power 2/3, which is 1 over 8 to the power 2 over 3, which is 1 over 4. So this is our x coordinate. And to get the y coordinate, I don't think we need that. So we're just going to substitute this. Wait, it says the coordinates of the stationary point, so we need the y coordinate. We need the x and y coordinate. So to get the y coordinate, we're just going to substitute the x here and the 2 for k. So k is 2, so 2, and we know x is 1 over 4, so just going to substitute it there. 1 over 4 to the power half minus our 4 minus our 4. Our x is 1 over 4. This time we are squaring it, plus 2. That is giving us our y to be 2 3/4. So y is 2 3/4. And for us to be able to determine the nature, we're just going to substitute this x value into the second derivative. And if we get a value that is greater than 0, it means it's a minimum. And if we get a value that is less than 0, it's a maximum. And so minus 1 over 4, our k is 2, then our 1 over 4 to the power minus 3 over 2, we to the power, let me just use this one, it's minus 1 over 2, our x is 1 over 4, and this being raised to the power minus 3 over 2, minus 1 over 2, 1 over 4, this is being raised to the power minus 3 over 2, right, minus 8, it's giving us minus 12. So minus 12 is less than 0, so it means it's a maximum. The turning point is a maximum at x equal to that. So these are the two coordinates, and this is the nature, and you get your 4 marks. And for the last question, points A and B on the curve is x coordinates 0.25 and 1 respectively, and says for a different value of k, the tangents to the curve at points A and B meet at a point with x coordinate 0.6, then it says find the value of k. So let's try and make use of the equations that we have already. So points A and B in the curve have x coordinates this and that, meaning this for A and this for B. Right? So let's try and get the y coordinates first when x is equal to that, using the original equation, which is this. So if x is equal to 1 for B, so y coordinate for B, coordinate at B, y coordinate at B would be, I was just substituting 1 here, so that would be k minus 4 plus 2, k minus 4 plus 2, k minus 4 plus 2, which is k minus 2. So it's 1 k minus 2 B, and the y coordinate at A, the y coordinate at A, we're just going to substitute 0.25. So this is root of 0.25, that's half. So half k minus, let me just write it, it's half k minus 4, 0.25 squared, it's minus 1 over 4, then plus 2. So plus 2, we get 1 and 3/4, so half k plus 1 and 3/4, that's the y. 0.25 is the x coordinate of A. Okay, we can still use the additional space. Okay, and so with this now, let's move on to getting the gradients, one at A and one at B. Since we're going to deal with tangents, now the gradient of the curve is equal to the gradient of the tangent at the point at which the tangent meets the curve. So we're going to try and get the gradient of the curve at A. So m at A, m standing in for gradient, just going to substitute 0.25 into our dy dx, 0.25 into our dy dx with k, yeah. So that's our half, or 0.25 to the power minus 1 over 2, then minus 8, 0.25, and that is giving me minus 1. So the gradient is minus 1, and m is minus 1k. So wait, it's half k. So let me check that again. It's not minus 1k down here, because we are using this right here. So we're saying half 0.25 to the power minus 1 over 2, that's 1k. So it's k minus 8 times 0.25. So it should be k minus 8 times 0.25, 8, 0.25, that's minus 2. This is the gradient. And m at B, we are substituting 1, x equals to 1 now. So that's 1 here and 1. So half k minus 8. So getting half k minus 8, right? And now from these two, we know that these are also the gradients of the respective tangents, one touching the curve at A and the other touching the curve at B. So we can go ahead and get the equations of the tangents using these coordinates and their respective gradients, right? And to do that, we can use y minus y1 is equal to mx minus x1, right? So for the tangent at A, we're saying y minus the y coordinate at A, which is half k. So you can just say minus half k, then minus, that's 7 over 4, is equal to m, that's k minus 2. Then it's being multiplied by x minus the 0.25, which is the x coordinate at A, right? And we know x with x coordinate of 0.6 at the point which they meet, and since we're going to equate these two, we can substitute 0.6 here, and 0.6 minus 0.25 is 0.35. So this whole bracket will give us 0.35. So simplifying that, we get y equals half k minus 7 over 4 being equal to 0.35 k minus 0.7. 0.35 times 2, and this will come down to be y is equal to 0.35 plus 0.5, that's our 17 over 20 k, then minus 0.7 plus 7 over 4, that's our 21 over 20. Now for the equation of the tangent at B, going to do the same thing. Y minus the y coordinate at B, that's our minus k plus 2, is equal to the m at B, that's our half k minus 8, and it's being multiplied by x minus the x coordinate at B, which is 1. Substituting the same x coordinate, which is 0.6, 0.6 minus 1, it's minus 0.4. So this will give us y minus k plus 2 is equal to minus 0.2k. We're now multiplying this with half k and minus 8, oops, minus 0.8, okay, it's minus 8 times minus 0.4, we get 3,2, like this. So this gives us y is equal to 0.2 plus 1, the 0.8k, then 3,2 minus 2, that's plus 1,2. Now we're just going to equate these two. Since they are meant to be equal, they share an x value, right? So 17 over 20 k plus 21 over 20 should be equal to 0.8k plus 1,2, like this. Alright, 17 over 20 minus 0.8, that's 1 over 20k, is equal to 1,2 minus 21 over 20, that's 3 over 20. And if we divide both sides by 1 over 20, we get our k to be 3. Just to confirm, it looks obvious, it's 3, so our k is equal to 3. And that brings us to the end of this question paper. If you guys are finding this content useful or helpful in any way, please do consider subscribing to my channel to get more videos.